Welcome back, everybody. I'm going to talk about the greenhouse effect, greenhouse gases, things like that. Pretty high level here. We'll get in deeper as we go. In the atmosphere, we have things called selective absorbers. And when we say absorbers, we're talking about absorbers of radiation, both shortwave from the sun and long wave from the Earth, and also from um, radiation that's reflected from the clouds and things like that. So selective absorbers are actually the greenhouse gases. In a nutshell, what happens is we have these greenhouse gases that are floating around in the atmosphere, and some of them, like ozone, will absorb UV radiation. Not all of it. Some of that UV radiation actually gets to the surface of the Earth and heats it up. Then once the Earth's surface starts to heat up, it will start to emitting its own radiation in longer waves, mainly infrared radiation. Greenhouse gases, especially CO2 and water vapor, are really good at absorbing infrared radiation. Methane and nitrous oxide and others aren't quite as efficient, but they still are efficient at certain wavelengths. Anyway, so those gases actually will absorb radiation, and they will re-emit radiation back to the surface. Because it re-emits radiation back to the surface of the Earth stays at a balmy 59 degrees Fahrenheit on average. Without these greenhouse gases, the Earth would still heat up, much like Mars does. But once the Earth doesn't have radiation hitting it, it would emit radiation and it would go straight out to space. And the surface of the Earth just would not warm up very quickly. In fact, without the greenhouse effect and greenhouse gases like CO2 and water vapor, the surface of the Earth would be approximately 60 degrees cooler, and we would not be able to live on this planet without the greenhouse effect and greenhouse gases. So they are important to have in the atmosphere, but a lot of what we will talk about specifically to climate change what we have done industrialization-wise over the last many years, specifically the last 50 years, has increased the greenhouse effect and increased the surface temperature and made it dangerous for a lot of different things, ecosystems and us and biological systems and other things like oceans and those types of things, ice sheets, all of that. So that's stuff that we're going to talk about throughout the semester is, what is the kind of optimized amount of greenhouse gases, and where are we headed if we are going to continue to increase the greenhouse effect that is climate change. Very quickly here, now this looks like it's hard to deal with. I get it. They're graphs, but it's really simple. Okay, these are different ranges of radiation. This is ultraviolet, this is visible, this is infrared on the bottom. This here is the percentage of absorption, of these different wavelengths. And these are different greenhouse gases. So nitrous oxide is actually really efficient at absorbing infrared radiation at these wavelengths. Methane the same, so it's pretty narrow band. Molecular oxygen actually can absorb radiation in some of these wavelengths, and you can see over here ozone is actually really, really efficient in the ultraviolet wavelengths. The very interesting thing here is water vapor and carbon dioxide both have pretty high efficiencies at certain wavelengths. Water vapor actually looks to me to have more efficiency at absorption of radiation than carbon dioxide, but carbon dioxide definitely does a good job along with water vapor at these long ultraviolet wavelengths here. So in a nutshell, at the bottom we go ahead and combine everything, and you actually have radiation that actually will seep through because we do not have greenhouse gases that will absorb at some of these radiations very efficiently. So some of this radiation will release out to space and not get absorbed. Some of it will get absorbed, and it's a kind of a happy medium with our atmosphere with regards to how heat is transferred, how it's absorbed, how it's re-emitted and released, in order to keep our temperature at levels that aren't disastrous for the way that we do business on our planet, specific to agriculture, trees, things like that. Now, it's not the only issue that we're going to talk about throughout the climate change class, because there's also human caused land use issues and things like that that have to also be a part of the discussion in this class. But specific to greenhouse gases, hopefully this makes some sense to you. Next slide talks about incoming and outgoing radiation. This is really simplified. Okay, so we're going to say, okay, if we thought about sun's incoming radiation on the order of 10 or 100 units, so we're going to think about this as a percentage. How much of it gets reflected, absorbed by the Earth, and scattered out to space? So of the 100 units, 51%, so you can think of it as 50%, is absorbed at the surface. So the Earth's surface absorbs about half the radiation. Close to 20 is absorbed by the atmosphere and the clouds, so greenhouse gases, clouds, things like that. And then 30% is reflected or scattered. 20% is reflected by clouds, 6% scattered by the atmosphere, and then 4% reflected from the Earth's surface. On snowy days, it's actually a little more, so that makes sense. But on the average, the Earth reflects about 30%, which is the Earth's albedo. So that's something that you need to know too. Albedo is simple. It's reflectivity. So the Earth's albedo is 30%, which means it's 30. It reflects 30% of the radiation. And then the last slide for this particular portion of the module just talks about over the globe, it is not continuous how things get, radiation hits the surface. Therefore, we end up with surpluses on the tropics because the sun gives pretty consistent radiation to the tropics, and then deficits at the poles, specific to what season you're in. So if it's wintertime in the northern hemisphere, you have a pretty major deficit in the poles because they don't get much sun at all. And then summertime in our summertime in the southern hemisphere, it's fairly similar. And then a lot of this heat, because the Earth's atmosphere and oceans for that matter, they want to be at equilibrium, we do get heat transferring from the tropics to the poles naturally, which aids in weather development, long-term climate, and those types of things. So understanding at a high level this process is also important when we're talking about climate change. Thank you.